How to graph a circle? Okay. All right, so let's say you want it in standard form, or you have to put it in that form first? Remember how we had to do completing the square to put it in the standard form?
Can we try that one?
Okay. So if we have let's say we have x squared plus 2x minus y squared plus y squared minus 6y plus 2 equals 0. Okay? And the question is graph the circle using the method of completing the square so that we can do this. All right. First of all, do you remember what you start with? Beginning point. Okay, you want to get all your constants on one side. So the only constant we see here is this 2, right? These are variable terms, the other constant term. So we start by just moving this 2 over here as a negative 2. Okay? So again, you move it to the other side, make it a negative 2. So now we've got equals negative 2 instead. Alright. Now after this, we have to think back and say to ourselves, we look at everything that has x's and everything that has y's separately. Okay? Starting with the x's, take a look at the middle term. See the b value here is 2? You always take half of that and then square it. That's the completing the square method. So half of 2 here is 1. And then 1 squared is still just 1. So you're going to add a 1 there. Okay, now if you add a 1 to this side of the equation now, you got to do it over here. So right now on this side we have this. Then you do the same thing to the y's. You take half of b. What's half of b in this case? Good. And then square negative 3?
9.
Good. So we have plus y squared minus 6y plus 9. If I add 9 over here, we've got to add 9 over here. Okay? Now, looking at these sets we have, think of it like that. How can you factor the first 3 in the first trinomial? Yes. So x plus 1, x plus 1. How can I write that in a simpler form to make it look easier?
X squared plus.
What if I had this? How about this? What if I had x times x? What does that equal?
2x. I mean, x squared.
X squared, right? Not 2x. Because what's 2x?
X times 2.
Good. Or if it's at x plus x, it's 2x, right? X times x is simply x squared. So when you multiply the same thing by itself, you just square it, right? Aren't these identical? So instead of writing like that, let me just write it the same way I did this, but squared. And this is where standard form of the circle comes from. Okay, so then over here, what do you got? How do I factor that part?
Minus 3 minus 3.
Minus 3 minus 3. So instead of writing it twice, I can just do this, right? Now over here, what do I get as a sum?
8.
All right. So think back now to circles. H, K, R squared. So what's the center of the circle going to be for the circle? The standard form of a circle. Okay, that's our standard form we're going to use. So utilize this from this equation to come up with those values. What is the center going to be? What is the radius going to be?
H is going to be negative 1.
Hold on.
K is negative 3.
Be careful. Because remember, the negative sign is already here, so we're doing that opposite there. And then what's the radius? It's not 8. Be careful. Why is it not 8? What does this tell you right here? 8 is taking the place of r squared, right? So 8 is r squared. So what's r?
Yeah, she right there.
Good. Because 4 is half of 8, right? That's the first thing you think of.
Leave it alone, man.
How we did like 3.
Well, just think, start over. How do you get rid of the square? What do you do to both sides?
I mean, call it.
What does it look like? Can I draw it? Good. It's called a radical, or you can say square root. So if you square root both sides, the square and the square root cancel. The radius is just the square root of it. Okay, so the radius is radical b. So when you're going to graph this, you got to go over 1, up 3. Okay, so we go over 1, up 3. There's our center of the circle. Now, how do you draw a circle? What's the easiest way to do it? If you know the radius. Assume, like the value of the radius is about 2.7. So assume you know it's 2.7, because I know it's tough to see. If it's 2.7, how would you graph
One second. Make the 4 points going all around.
Hold on.
So 2.7 going to
And a little bit more.
no,
Well, this would be down 1.
no,
This would be
down
down
2.
2. This would be down 3. We don't go that far, so a little bit above there.
Here, 2 over here.
Yeah, you're gonna have to extend. Okay. No, you gotta go 2.7. You're doing 1.7 again. Good. Keep going. Good. Second. Good.
So 1, 2, 2.7.
Okay.
Okay, this is 1, 2. 2.7. I go up 1 more, right?
You tell me. I don't know. Come on. Count.
1, 2, 2.7.
There you go. Good.
Here. 1, 2, 3, 4, 7. Here.
Okay. Not bad. I mean, your circle, but again, how I tell you, when I teach you how to draw a circle, I always want to draw it as 4 arcs. Because if you try to draw it at 1, you're going to get like a diamond shape, which looks like you have. Draw your arcs. Get all 4 your arcs in there, so it looks a little bit smoother. Okay, that's good. Very good. So this is graphing a circle using the method of completing a square. Had you just been given the equation to start with right here, you could just simply identify your center and your radius and then go right to the graph. But had it been given in your normal or your polynomial form, you would have to put it into completing the square form. Come on in, guys. Why don't you grab a seat? Why don't you guys grab a seat on this side over here? Do you need the rope for anything?
I'm actually going to be probably seeing files in the same structure, but.
That's fine. Yeah, they're going to be on this side.
Yeah, bringing a ladder.
Oh, you're waiting on that?
Yeah, I mean, it's supposed to be bringing a ladder, so.
Okay, I mean, I have lunch, so.
Right.
Which
I'll start up here sometime anyway.
Okay.
Stuff.
If you
I
need that
need
side,
to
we'll
come
just
in.
rotate stuff, that's
Sure.
fine.
I'll say for when they get there, I can start a room next door, so I can do both these classrooms, so that way.
If they're open, that'd be great, yeah.
Yeah.
And I think, I mean,
Yeah, that'd
my
be
estimate is that people will be here probably till about 2:30 is my time estimate for
Okay.
students. But it could be more, it could be less, depending on who shows up.
All right.
All right. So he asked a question on graphing circles we just went over, so that's already recorded. So if you want to catch up on that later, you can. What are some topics that did struggle with? That's 55? Okay, which we're talking about there, exponential, natural base e, right? E. Okay. So first of all, let's start. This e, what does it really mean?
2.17.
Yeah, 2.71, something, right? It's that whole thing. So this is that decimal that goes on. It's very similar to what other constant that we've used in geometry a lot? Pi. It's like pi, it's another constant, okay? So let's start with that, because you have to know that that's what e really means, all right? Now, with concept 55, we looked at the exponential function, and we looked at this function that I'm about to write here. This is y equals a e to the rt. Remember that function? And it's the exponential function. So this e is that e that you're seeing up there. What was r again? The rate. R rate. T is? Time. And a is? The initial or the starting point, okay? And I think of a as amount, okay? But it's the amount in the beginning. A lot of the time, a lot of textbooks write like this. Which is the same thing. See y0? Whenever you see a little 0 subscript, it means initial. So y0 just means the same thing as a. It's the exact same thing. And in your homework, I gave you guys an example with population, and I said p equals p0 e to the rt. P0 just means initial. Whenever you see a little 0, if you see V0, initial velocity, okay? I know initial starts with I, but 0 is standing for like the 0 time period at the beginning, right? What's the initial when time equals 0? That's the beginning. So this is the equation we've been using. Now, the types of questions that I gave you on these were all application-based. So for example, like you have bacterial growth, or you have a virus, or you have a rumor spreading. That was one of the homework examples. So do you want to just go through an example of this? Would that be a good way to do it? Because you asked the question, so I want your input. It's not about me. It's about you. Sure. That works? Okay. If there's something else that you'd like to do besides that, like if you didn't know what these meant and we just went through them, that's all you needed, just tell me to stop. But if you want to do more, you know what I mean? So I want to see what you guys want. I don't want to just stand here and talk. Okay? All right. So for an example of a problem like this, okay? Let's say, pick an animal that, sorry, you don't like because it's going to be endangered soon. This problem here. Pick an animal, sorry, that's bothering you. Sorry. What animal?
Tiger.
A tiger, okay. And tigers are actually going endangered in some spots of the world, so that's not a bad one. So let's say the tigers of a small island off the coast of Africa. And you guys can just listen. You don't have to write everything down. You know what I mean? It's all recorded, so you can even watch it later too. Off the coast of Africa, on a small island, are being hunted, and there are currently 2,000 left. Okay? You trying to get it?
Yeah.
The binder's much easier. Just take a binder and just whap. Off the coast of Africa. This guy's getting in the room before he hits you. Watch out here.
Oh, it's a bee? I don't bees.
Sorry.
You have
I'm missing
bees.
someone.
There it goes. You got him.
I think I walked to the wrong classroom.
Don't run, Bridget. Don't run.
No.
Sorry. All right. So off the coast of Africa, there are 2,000 of these tigers now. So currently there are 2,000, right? The decay rate of the tigers is 4%. And I'm going to put exponential. When you see that it's an exponential decay rate, you automatically think of that formula we just talked about, okay? When, well, let's do two parts. Let's do two parts of this problem. This is a good one. Part A. How many are left after 5 years? When will there be 1/4 of them left? Okay? So two parts of this problem. I need a starting point or something to begin with. Somebody give me some info that I can underline or circle or whatnot. Okay, your A is going to be 2,000. Good. That's what you have to start with. Very good. Roll.
4% is the rate.
Very good. And as a decimal, can I convert that over here on the side, please?
0.04.
Very good. 0.04. And again, you notice is a lot of people made a mistake on their quiz. They put 0.4. Okay, so it's 2 decimal spots over. So 0.04. Very good. So we know our rate and we know our A value. Okay, and what is our equation again? A e to the RT. A e to the RT. Good. So we have the equation y equals A e to the RT. And again, we know that A is 2,000. And we know that the rate is 0.04. Well, the first part is easy. How many are left after 5 years? So for part A, when 5 years occurs, what does that mean? Good. So t equals 5 for part A. So for part A, they're saying, figure out how many are left when t equals 5. So look at your formula. Now you've got everything. You've got the A value here. You've got the R value here. You've got the T value. Just plug them in. You get your Y value to see what's left. So here we'd have Y equals 2,000 E to the 0.04 times 5. And whatever that turns out to be. Okay, just to do one quick example of that multiplying, because I know the E button tends to confuse people. All right, so let's say we got 2,000. Now, you can use either E. You can use the E by the division sign or the E down here. If you use the E down here, it automatically opens up an exponent for you. So I use that one because that's where we're doing exponential parts. Times 0.04 times 5. Again, my rate is 4%. My time period is 5 years. I started with 2,000. Now, for my rate, what should I put in front of my rate before I hit enter?
Negative,
Why should I put a negative sign?
because the tigers are decaying.
Decaying. Very good. Okay, so let's make sure we go back here. Oops. And put second insert, a little negative sign there. Okay? And take a look. If I didn't do that, let's say I didn't do that with the negative sign, I should have had a red flag pop up and say, that doesn't make sense. Watch what will happen here. Didn't that number go up? Again, notice at this point here, if I forget to put the negative sign, in front of the rate, the tigers are going to increase. They're going to go from 2,000 to 2,400. But I just said they're endangered, right? They got to go down. So that indicates to you have to have that negative sign. Okay? So our number is 2442. And again, sorry, let me put the negative sign here because I forgot to put it there. Okay? 22, what did I say, 49? 2442.
Daniel Rubio, if you're still in the building, please come see Mr. Childs.
Sorry,
Daniel
guys.
Rubio, please come see Mr. Childs.
What did I just write down? I wrote down the second one. We're going to 1637.
I was wondering, I was
Yeah.
like,
Please correct me. Sorry about
Yeah.
that. You got called down, Daniel. I heard you, right?
Yeah.
Why is the smoke? We're not agreeing. There we go. Okay. So, first of all, just to do a sanity check, clearly I'm going a little sticky tonight, right? I forgot the negative sign in the rate, which automatically when I put it in there, I was thinking about, okay, that must indicate that there must be a mistake. Let's go back and see. So when you come across these things on tests, it's not a bad thing as long as you know how to fix it. You know what I mean? Because sometimes once in a while you're going to forget a sign. You got to look at your answer and see if it makes sense. When I started writing down 2400 there, I was like, wait, that doesn't make sense. There's no way. Okay. All right, part B is the harder part. How do I do part B?
you got, take the 1637 and you put that as your, 1637, then you put E, then you put, negative. No.
Sorry, go.
We're going to use our calculator here. Yes, we're going to. One-fourth of them left. That doesn't mean of what's there. One-fourth of them left means like the original. How many did you start with?
2,000.
What's a fourth of 2,000? 500. Right? 500, 500, 500, 500 is 2,000. So the question is now asking us the following. It's saying, when will there be 500 left? So you have the following. You have, remember the equation, y equals a e to the r t. Now, we don't know t in this problem, right? It says when. The problem asks when. We're looking for t. So because we don't know t, we leave that blank. So we put this in y2, y1. What do we put in y2?
5.
The amount that we want to have. Very good. Okay, because what are we really doing here? We're really saying 500 equals this. So we put the 500 in one y, or y2. We put the other equation in y1, and we graph them to find the intersection. All right, let's do this. 2,000 e to the point of negative, see, negative 0.04 x. That's my y1. y2 is going to be 500. Now, before I graph these at all, let's think about this logically. What's the starting point for my function? 2,000. So let's go to our window and go to our y max, make it 2,000 here. Okay, make that 2,000. Now, the y min we can leave as 0, okay, because we know we're not going to have a negative amount of tigers. Doesn't make sense. So leave it as 0. The time, though, right now, I have it going from 0 to 10. And you can see the preview of the graph over here, can't you? They're going to meet a little bit further down. So if you just graphed it with 0 to 10, because I know you don't have the preview on your calculator, that's what you would see. You would see the exponential decay, and then there's the flat line at 500. So remember, this is 2,000 coming down. This is 500. Where are they going to meet? Yeah, further down the road. So what should I do, Bridget?
You should plot your, X max more,
Make it? It's a guess, obviously.
for 500.
500 from 10? Okay. No, let's try it. I want to see what happens. I'm curious. It might be right. It seems very large, though, to jump to be honest, but I want to try that just to see. Yeah, that doesn't... I mean, it works. It clearly works, because there's the intersection, right? 500 is really far, so you might not want to jump that much. Let's go to 50, just to make it a little clearer. Is that okay? And you'll pick up on this as you do this more and more. You'll notice, realize that, okay, it might work a little bit closer. So this works. 50 works a little bit better, right? You can see a little bit better there. So what are we trying to find again? The what? The intersection. The time. The intersection. Very good. The time. And the time is the intersection. So second, calculate. Number 5. First curve. Let's move over a little bit. As long as it's close, you're good to go. Enter, enter, enter. They're only going to intersect once. So the problem with, you know when they ask you for the first curve, second curve, and guess? It's in case there are 2 intersections. And it has to know which one it's closer to. But this is only intersecting once. So it doesn't really matter. You can actually just hit intersect, enter, 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 and you're done. So how many time periods go by? 34.65, whatever that happens to be. It could be days, it could be months, it could be years. It's too late.
I wasn't here yesterday.
Where were you?
I was going to say.
And why didn't you put it on my mailbox when you came in this morning? Where have you been for the last hour and a half after the exam?
I was with Miss Jenkins.
And you weren't doing Adderall?
I was starting for a job. No, okay, look, I was recovering because I finished it all, but it was in pen, so I printed out a new one and copied it in pencil.
Put it on my desk. So we don't know if this is months, days, years, because it wasn't given in the problem. Okay, so we don't know what the units will be. We could just say 34.65 or 66 time units. You saying, John, for review?
Yeah, I'm gonna get with it.
Okay.
What was the X-min?
What was the x-min? In this case, I made it 0 because think about it this way. X represented the time, right? X is the time. Y is the amount of tigers left. Can you have a negative time, really? No, it doesn't make much sense, right? So that's why I started with x-min as 0. So I'm really in, if you notice, by the way, Bridget, if you notice, I'm in the first quadrant, aren't I? That's what's going on here. Here's the y-axis, and here's the x-axis, okay? This is the origin right here. A lot of these problems with exponential growth and decay, you only have to deal with the first quadrant, because you can't have a negative amount of bacteria or tigers. You can't have a negative time. So since everything's positive, you are strictly working in quadrant number 1. Quadrants 2, 3, and 4 don't really matter. Okay, these don't matter. All right, let's continue.
I have a question.
Yes.
Say you finish the problem like that and you like type different numbers in your x-min and your y-min, but then you move on to another equation where you can't, well those numbers for the mins won't make sense. So how do you like, you know, like is there like a regular setting you can just like press
Yeah,
down?
zoom 6. So watch. Hit zoom and see standard. You're asking for a standard, right? When I hit 6, it automatically goes back to the 10 by 10. Okay, zoom 6. That's why in class, whenever I say when you're starting, like, okay guys, start with zoom 6, you know, zoom 6 it. It just means standard zoom. And Bridget, there's a bunch of other ones on here also. I mean, zoom in, zoom out, zoom decimal, zoom square. You're not going to use many of those. You might use zoom in and zoom out. Zoom trig is good next year when you're doing trigonometry. Zoom stat was very good. Where's zoom stat? Number 9. When we did the, remember we did the data points with the M&M lab?
Yeah.
That was for zoom stat. That helps. Okay? Zoom fit. I don't know what zoom fit is. Let's see what that does. Yeah, I don't know how useful that one really is. It tries to pick a graph for you. Zoom fit is like a calculator trying to predict what you want. That doesn't really help us too much though, right? That's 2,000 right there. That's like the 500 down there. I don't know what, they just wanted to get both graphs on there together. They don't show the intersections. And take a look at the window. It like picks random numbers on the window, see?
Mr. Howell.
Not random, but arbitrary.
Did you put up the video for yesterday's content?
Yeah. Put it up yesterday actually. It's up there.
Okay.
All right, next question. So we did so far an example of circles. We did an example with exponential growth and decay. Right? That was circles was yours, exponential growth and decay was yours. 55.
One more question about the exam, just to know what I should go over. Are you gonna like, is the exam like, is it gonna cover everything from like beginning of the year, everything you learned from first concept?
Everything you've done is fair game for the exam. Absolutely.
Yeah, but they're not gonna be able to come back all of that on the exam.
Maybe they are. You have to study everything. You need to assume anything is possible. Just like in college. I took a lot of classes where there's so much material that you know you could be tested on all of it, you know? But you have to assume any of it could be on it.
Have you seen it?
I have.
What is my
I can't tell you. That's part of the idea that you're supposed to know everything. Okay, I know some teachers do that, but I don't think that's fair. If I tell you what's on it, then you're not going to study the other stuff. I want you to Google around the material. I'll tell you now, though, you definitely need to study, but it's not as tough as my exams. Problems are not as difficult, but it's still like one of those tests where if you don't study, you're not going to do well. You need to have that, you know, that recollection in your memory from recent studies, especially from the stuff in the beginning of the year. You know, remember all that stuff we did at the beginning of the year? That's the stuff that is like, you got to make sure you go back and really look at. Just because we're so far ago, not because it's on the test form. Other topics of concern. It's up to you guys again, I said, so you can pick some ideas, some things that you're going to have trouble with. Whether it's graphing something, whether it's word problems in certain topics, depending on whatever it is. Yes? The first one. Okay, so that I'm not going to do because I already did. I already recorded the answers to that. It's on Edline. I'll show you real quick, just so you guys can see. I'm not going to go over the review packet. It's just a waste of your time because it's on Edline. Hold on, let me just show you where it is so you can all see. And for any of those that are watching also. All right, so depending on which section you're in for my class, it really doesn't make a difference. So I'm just going to go to any of them. So any of the Algebra 2 sections, just go to yours, obviously, you go to yours. And what you're going to see, under news, I put the recent stuff for logarithms, but it's also under news if you look under news. But it's actually right down here, too. Okay, look on the calendar. Final exam review sessions, that was the notes I put up there. I said when I'm going to have the review sessions. And that packet that you just pulled out, the one I gave you a few weeks back, here's the solution for the first part with all the multiple choices. It's just a video I recorded. I did the whole thing when you guys weren't here during the day. And then this is the recording, the solution to the graphs, and the part 2 is on there. So it's all recorded, so you can just fast forward to whatever problem you need to go over. And I wrote it all out on the board and stuff. Okay? So this one's about 45 minutes here. This one's about 20 minutes. So it's about an hour to go over the entire packet if you want to watch the videos for. Rich?
For concept 26 through 28, when you're like find the solution to the system by hand.
So substitution, elimination, you want to do?
Yeah.
Okay. So we got, let's say, this is a good topic to know, guys. Definitely a good topic to know. 2x plus 3y equals, let's say, 1. 4x minus 5y equals 13. Okay, so a system like this, Bridge? Okay. Or is that too complex?
No, like a
3 by 3?
like a little fighter, because you just take the pretty much move everything to the side so the y equals that, and then you plug it into the.
You could do that, but I don't do that method. Remember I told you guys to do elimination instead? Substitution is good when everything is variables, but here I would use elimination. Let me do this and then I'll go to the next one. If I just take the first equation and multiply the whole thing by -2, this will make this a -4, won't it? And this -4 and this 4 will cancel. So this is elimination method. So our operation is -2 times the first equation plus the second equation. Okay? So we're going to have -4x minus 6y equals -2. That's what this first equation is going to become. And now we can simply add these two together. Okay, so again, I'm going to take these two now, and I'm boxing in, and add those two together because the 4x's are going to cancel. So those drop off. I'm left with -11y equals 11. So what does y equal? What is it? -1. That's the solution for y. Now once you know y equals -1, you can go ahead and plug that back in up here. You get x. So if I take the -1, plug it in right here, this is going to become, take care, John, this will become -3. I'm going to then move the -3 over here by adding 3 to both sides. So I'm going to get 2x equals 4 plus x equals 2. So my solution is simply 2 and -1. So if I were to write it as an ordered pair, my solution would be 2, -1. Okay? Now, there are other ways to solve these problems. As Bridget said, you can solve for y in one of the equations and plug it into the other, which is called substitution method. That's a fine way to do it also, but that doesn't necessarily make it easier. Another way to solve these, believe it or not, is to graph them and find the intersection. If you graph these, the intersection on the graph would be the point 2, -1. Remember, the intersection on the graph of two lines So let me see. I can visualize this for a second. This one's gonna look like this. That's the top one up here that was original. And the second one.
It's so bad.
Like this. Okay? And notice right away, what's the coordinate? This is over 1, 2, -1. There's the intersection at 2, -1. Okay, so the solution, if I graphed, again, this is the blue line is this one up here. The green line is the graph of that one. That's what I'm sketching. And if you see, where do they intersect? It's at 2, -1. What was our answer? 2, -1. So whenever you have these problems, if you can graph them, that's another way to do it. These are not hard, these are not easy to graph because you got to solve for y, right? Or if you're graphing by hand, you can do that by finding the intercepts, the x and y intercepts, but that's messy. If there's anything bigger than a 2x2 system, though, I would recommend for now just use the matrix. Remember the matrix for this stuff? So
Yeah.
the matrix for this one would be 2, 3, 1, 4, -5, 13. Okay, again, remember 2 is here, 3, 1, 4, -5, 13. That would be the matrix. I will plug it in right now. So let's say we're solving that. 2, 3, 1, 4, -5, 13. All right, so we press second, and the matrix key right here. Okay, second matrix. We go over to edit, hit enter. It happens to be the right size, but in case it wasn't, remember I want to have 2 rows and 3 columns for this example we just did. So it happens to be the right size. But if it weren't, I would type 2, enter, 3, enter, and it would show up. Now, our numbers were 2, 3, 1. So 2, enter, 3, enter, 1. It's not 0, but 1, enter. And 4, -5, 13. 4, enter, -5, enter, 13, enter. Not 133, 13. There we go. Now at this point in time, that's my matrix, but I want to reduce it. Remember, RREF is the reduce function. So I quit out of here. Second, quit. Clear the home screen just to make it easier. Now I press back to matrix. Second matrix. Go over to math. I want to go down. I'm just going to go up instead. It's a shorter cut. Press up and go up to RREF, choice B. Okay, my calculator program froze, unfortunately. Give it a sec. So you're going to go up to choice B, which is RREF. Okay? You're going to hit enter. Then you're going to be back at the home screen. You're going to then go back into matrix. You're going to go back into matrix. Really? You go back into matrix. So that's what's on your home screen right now. You're going to see parentheses. Hit matrix and just hit enter on A. And you'll see the matrix A appear like this. Okay, then close your parentheses, hit enter. You should see something that looks like this. That agreed? Okay. What does that tell me? Is that what you're seeing out here now? You press second matrix to bring up the RREF. Did you get that done? Okay. And you got the A there or no? Then you hit enter. Did you get this? Okay, that means you entered the wrong numbers in the matrix. Go back to your matrix and relook at it. Check with Miguel. Match them up, because my program obviously is not working right now. I don't know what happened to it. It's frozen completely.
What does the RREF stand for?
Row reduced echelon form. And all it means, I'll explain it. It's not very difficult, but people don't sometimes say it. It's very easy to do. Row reduced means that these rows have only ones and zeros in them. And echelon form means it's down the pivots. The ones are like this. They're diagonal ones. That's the reason it's called that. But the important part is to know this. Remember, this was where x came from. This was where y came from. This was where the constant came from at the end. And it looked like this. Remember our equations? So this means that we have 1x plus 0y equals 2. Here we have 0 x's plus 1 y equals negative 1. Well, simply stated, the y here doesn't matter. It's a 0. This is also a 0. So you have x equals 2 up top. X equals 2. Here you have 1 y equals negative 1. Y equals negative 1. Same solution we got before, just a different way to get it. I would really recommend, though, guys, for the sake of the test on Tuesday, if you do get a system and it's given in form like this, just do the matrix right away. I mean, honestly. Because think about it, right? It's a standardized test like this. You want to save time, like the SAT style. I would not solve that by hand. I'd go right into the matrix, got to come up with a solution like that. Especially if it's a 3 by 3. Okay, if you have 3 by 3 like X, Y, and Z, definitely use matrix.
That's for substitution.
Sorry?
That's for substitution, right?
That's in place of substitution, sure. 'Cause substitution would mean you have to solve for Y and plug it in over here to get X. Now you can use substitution, but I wouldn't choose it. I definitely wouldn't choose it for this sake. What else? Other topics. So that's systems of linear equations there.
What was that topic? It was 25.
21?
20 to 25.
But we have to find out the axis of symmetry.
Yeah.
Right?
So quadratics?
Yeah.
What specifically though? There's a lot that we do. We do so much of that. And ask yours while he's checking there.
We have some,
Conic sections. Conic sections? What about them? Okay. So I'll give you an example of an ellipse. For an ellipse, if we had an ellipse on a graph, and the ellipse looked like the following. Alright, for an ellipse, what do we have inside of the ellipse that indicates part of it? What do we call that for the ellipse? What are these things here? Like I have a little x here and a little x here. What were they considered to be? Not the vertex. No, that's the other, you're thinking in other words, those are my outside parts. What are the x's called? Nobody remembers? Foci, focal points. FOCI. This is one focal point. That's another focal point. Instead of, remember how a circle has only one center? Remember, the circle has a center. When the circle begins to get stretched, it can't still have a center. It's got to have two centers now almost. Those are the foci. FOCI. These were called the vertex and the vertex. And this was the covertex up here, and the covertex. Okay? What was the line from the vertex to the other vertex called? Nobody? Major axis. You guys got to study a little more. And that's minor axis. Okay? Major and minor axis. So if you're given a graph example and you have to graph one of these, again, the test is not going to test you with equation stuff. It's going to give you properties. It's going to say the vertex is at this point. This is at this point. Show a graph. And I think before I'm not going to go into this because you're all a little bit lost. You need to study this before you go any further with this. This is not going to help. I mean, just sitting here telling you these words. Okay? It's not really emphasized so much on the test, to be honest. Conic sections. There's not too much for it. Hey guys, did you figure out what the question you had was?
Yeah. The basic equations.
Okay, so the three equations?
Yeah.
Alright, so we have three forms, right? The first form, what do we call that one?
Standard form.
Good, standard form. Second one? Good, vertex, because you see HK, right? Third form? Intercept, because x1 and x2 are the intercepts, the x-intercepts. For the first form, it's good to know that x equals negative b over 2a is called what, Bridget? You called this before? intercept. Cuts the parabola in half.
Axis of symmetry.
Very good. Remember, A and B come from the equation. That is a vertical line. It's got to be a vertical line because it says x equals. Whenever something says x equals, it's always a vertical line. Okay, what else? What's the C value indicate always?
Y.
The y-intercept. Good. The C indicates the y-intercept. What else? Quadratic formula. I mean, you have to either memorize it or use the program that we wrote, one or the other, so you get the roots. Okay, so this problem is up here, right here. If you want to find the roots of it, you can either factor it into something that looks like this, or factor it and then make a t-chart. But if you can't factor it, you got to use the quadratic formula or the program. How do you find the vertex when it's not in vertex form? When it's in this form up top? What's that dashed line called again? Doesn't it go through the vertex? So if we get the axis of symmetry, let's say the axis of symmetry in our example turns out to be like 4, or x, obviously x equals 4, okay? And I want to know the vertex. What do I do with that 4? Because this line is, this could be x equals 4 right here. Right, here's 1, 2, 3, 4. How do I find the vertex of the parabola now?
Y.
Yeah, you need to know the y coordinate, right? So what do you do with the 4? Where? Where? Equation. For A, B, C, X, Y.
What should you put into X?
Yeah, because it says X equals. It's not a tough question, guys. You gotta answer it. Come on. If X equals 4 is the axis of symmetry, that means that all these coordinates have a 4 in them as the X coordinate. But you want to know how high up this is. Well, it could be up 1 unit, or this could be up 2 units, or it could be up 4 units. We don't know the height of it, right? So if you have the axis of symmetry equals 4, you take the 4, plug it back in here and here. You'll have A, B, and C, obviously, no real problem. You get a Y value. So this coordinate here is 4, comma, whatever you get for the Y value. Remember, the axis of symmetry and the vertex have the same X value always.
Wait.
Haven't seen. Oh, home.
Oh, you went home?
Yeah.
Do you know if you sent us directions about the final exam and deadline?
He did not, but I can tell you if you want to.
Is it easy to do?
Yeah, it's the same exact thing as the midterm. It's
Why just
identical.
call it final?
Just call it final, and then when it comes up, it's going to say S1 or S2. You're going to type in a 2.
Thank you.
You're welcome.
So wouldn't you just take the C value and just put it into X?
The C value and plug it with the X. What do you mean?
You said the C value is the Y.
Intercept.
The Y-intercept.
That's this location right over here.
Oh, okay.
The Y-intercept, not the vertex. The K value is the Y coordinate of the vertex. The H value is the X coordinate of the vertex when it's in that form. When it's in factor form at the bottom here, well, what does that help me with? How can I graph something that looks like that? Or what can I do with that equation? Yeah, you get the points. What points though, Karina? Good, on the x-axis, well done. Again, if you have a parabola here, this point here and this point here, they come from this factor and this factor, or by using the quadratic formula if it's in this form. So it doesn't matter what form it's in. And the other thing you can always do, guys, even if it's in vertex or intercept form, you could always multiply it back out to get it back into standard form. Right? You can just FOIL this out, put it back into standard form. Okay, so let's look at one example of this. We have y equals 2x squared plus 4x minus 7. What would the axis of symmetry be for this? Axis of symmetry? Not roots. Axis of symmetry. You're going to need the roots eventually, but I'm not asking for that right now. What's the axis equal to again? Are you going to be over? Thank you. Write it down, guys, if you don't know. Come on, write it down. If you don't understand something, that's something that you should write down. Negative b over 2a is negative 4 over 2a. Well, it's 2 times 2. So this would be negative 4 over 4, which is just negative 1. So already I know that my graph at the line x equals 1, negative 1, with the line x equals negative 1 as its axis of symmetry. All right, what else do I know about this? Okay. Good, but how do I figure it out? What do I do? Good. So we'd say negative 1 here, plug the negative 1 over here, and minus 7 to get our vertex. Very good. Negative 1 squared is 1. 1 times 2 is 2. It's going to be a negative 4, negative 7. That's negative 11 and 9 is negative 2 is negative 9, rather. So that's the y value of the vertex. So to find this vertex or to show it, you go over 1 and down 9. So it might be down here. Let's say that's 5 and that's 10. Okay? So my vertex is at negative 1, comma, negative 9. Okay, that's the vertex right there. Negative 1, negative 9. What else do I know about the graph? The roots. How do I find the roots? Okay, but don't forget, if you're going to do that, you got to use AC method, right? Look at the front here. You got to use AC method here. Or use the quadratic formula, or use the quadratic program. Run it through your program. Run the 2, 4, negative 7 through. Tell me what you get. Point. Was this 1.12? Like that? Yeah. Okay. So those are my roots. So about positive 1, which is over here, and around negative 3, which is about over there. Okay? Again, I'm estimating. And notice, what do you notice, people? The axis of symmetry is halfway between the roots, isn't it? Look, this goes over like 1, 2, right? This is like a distance of 2, and this is about a distance of 2. It makes sense because it's symmetric, right? So if one root is here, the other root's got to be over here, equidistant from the axis of symmetry. What's the last thing I also know about this graph? One other thing. It's going to what? Okay, it's going to definitely open up. Why is that? Yeah, very good. A is positive, people. Look here in the front. When it's a positive leading coefficient, it opens up. It's concave up. When it's a negative in the front, it opens down. It's concave down. I do know one other thing, though, so that was additional. There's one other thing I know. Look at the function. What does the negative 7 represent? C, which is what? What? Y-intercept. Y-intercept. So the y-intercept is right here at negative 7. Okay? There's my curve. There is, I think, only 1 or maybe 2 examples in the entire test where you have to actually graph. A lot of them are, they give you a graph and say which equation represents it, and there are multiple choices. So what can you always do if you have the equations? Yeah, you could check them in your calculator. Or they might give you one equation. They might say y equals 4x squared plus 3x minus 7. Which of the following choices is the graph of that? Again, you can just plug it in your calculator. You're allowed to use your calculator, so utilize it as much as you can. Okay? Make sense? That's why, again, I'm not always agreeing with the test. I'm glad that you guys will be able to do well in it. Sometimes they don't really test you on graphing because you can just go right in there and graph. But if it helps, helps.
And will it be for response?
Yes, the test is pretty much half multiple choice, half true response. That's the general setup for it. Next question. Sorry. We're going to do another session on Monday. We can do more on Monday if you guys want to have more questions for Monday. Yeah. mean, it's up to you, you know? Is anybody gonna come in on Saturday for expo or for study periods? Did they announce that yet?
No, they never announced it.
It's supposed to be like 10 to 2 on Saturday in the library, open hours, kids want to come by. And I signed up and I said I would help from 10 to 2, from 10 to 12. I'll run it. So if you want to come in on Saturday from 10 to 12, then I'll be here. If you want, or Matt help, if you have other help, you want to come also, just do that.
So if you can be on Saturday, we should come like, go ahead and line, check out the concepts, everything, and bring up the.
Yeah, come like, just come with questions, bring a whole test, bring stuff you had trouble with. I want to work on stuff that you need help on instead of just sitting here doing questions. Because sometimes it doesn't make sense, you know, if you do something that you're really good at already, why would I sit here and do that, you know? I'd rather you guys just come in and ask, and I can help you with another. Okay? Alright, cool. No problem, guys. And I'll put this on headline, so if anybody from the class asks, it's 50.